Okay, so till now we have created multiple files, one for Gradio, then Streamlit, then for application, web application, and then API also. So let's create one simple file which will include web application as well as API. So on cloud deployment, we are going to use that simple app.py file, which will have your web application as well as API in one file only. So once you start your server, you will get entire web application as well as API, and that file we are going to deploy on the cloud server. Okay. So I have created this app.py, which will just a combination, just a addition of Flask API.py and Flask web app.py. So we don't have to run these two servers separately, because for API you will run one server and then web application you will run one server. So instead of that, we will combine the code from these two files into one single file, app.py, and we will start one single server. So all the code inside this app.py is repeated. So again, same, you need to import few modules like Flask, render, template, session and all. Then as usual, helper function. From config, we are going to import the configuration parameter and then logging. So once we log the data, once we create the logging module, we will create Flask application with this secret key. And then first we will create a route. Again same, this is similar to Flask web application. So first we will create a home route which will have get as well as post. Both the method, means user can get the data and post the data. These are the data that we will fetch from the session variable. We will store inside the session variable once user click on submit button, and then user will redirect to prediction endpoint. So here we will extract the data from the session variable to data dictionary, and then we will pass that particular data to inference pipeline function. So this inference pipeline function will return the final result, and we will send that data to the client. So this entire part is for web application. But now we will copy the entire Flask API part inside this code only. So if you see, I have created another route, and this time the route is /API/prediction, and the method is only post. Means user can go to this particular route, but only posting the data, not getting the data. So for this, you have to use either Postman, or you can use Python request library. Again same function, like take the data, JSON data, pass to the return prediction function, it will return the result and return the JSON object. And let's say if user make any mistake, then we will directly go to error handler part, which will display or render the not found.html template. And then lastly, run the same application. So in this one application, I have created 4 routes. First is home route, second is prediction route, third is API route, and the fourth is not found. If user does not found the page or maybe any mistake in the page, then this route will be applicable. So these are the 4 routes that we have created in app.py. So let's run and test this entire app.py file, because at the end we are going to deploy one single file on the cloud. So let's run Python app.py. Now I am currently running only one single server using app.py. So let's go to this link, and here we can see the web application is working perfectly. We can insert the data. Let's enter the full name, age, gender. So you can see the male and female is not properly aligned. So to resolve that thing, you can use CSS. Enter occupation mode in number 4, enter sleep duration, quality of sleep, physical activity, stress level, BMI mode, enter heart rate, daily step count, then systolic, diastolic blood pressure, and additional comment. Additional comment won't be used for the model building. So I am just passing some random data, and then let's click on submit button. Okay, and we got the numeric data, and congratulations Dev, your models predict that you do not have any sleep disorder. Okay, so the web application is working fine, and here we can see we got the prediction prediction result none, and we got prediction. So this particular data we got it from the web server. Now let's test the same thing using Postman. So let's open the Postman, and here we just need to change this particular URL, not the remaining thing. So first let's see the IP address and port number. So IP address is 192.168.1.57. Port number is 8080. So here the IP address is again same 1.57, but the endpoint needs to change, and the endpoint is API/prediction. Now if I click on submit button, it should return the response. So let's try this. Okay, there is some issue. We did not get any response. Let's test it. Okay, let's copy the URL again. Okay, the port number is 8080, and we'll see which port number. Yeah, so the port number is 5080. So here we will use 8080, and let's send the request again. And see, we got the prediction none. Now let's go to PyCharm and see we have prediction from the API. So if you run app.py, you can able to run your web application as well as API. So using one .py file, you can run both the thing. Okay, and similarly you can run that using request.py also. You just have to change the endpoint, API/prediction, and endpoint is 8080. Now the server is running on this particular terminal. Let's go to another terminal, type python request.py, and see we got the final output. So means we have successfully built our entire web application as well as API using multiple technique. Now the time is to deploy the entire web application to the cloud server. But before that, we need to push all the code to the GitHub repository. So it's a best practice. But again, before pushing the code to the GitHub repository, we need to add a few more files. So let's do that thing first. Let me terminate the server first. So using Control C, you can terminate the server. Let's close all the terminal. Now there are two files missing in this entire project, and those are very important. First is Requirement.txt file, means how you will know which libraries and versions I am using for this particular project. So we have installed couple of libraries in disorder prediction environment. So let's create Requirement.txt file. So let's go to terminal, type pip freeze angle bracket requirements.txt and click on enter. So you don't have to do this manually. You just have to write this command, pip freeze requirement.txt, and here you can see the requirements.txt file is created. So if you open this, here you can see all the libraries which we are using for this particular project has been added in the requirement.txt file with their specific version. Now here you can see torch vision we are not using directly, so you can remove that. So it's basically a sub dependency of any particular library. But directly we are using Jinja, Flask WTF, Flask library, then sklearn, Pandas, NumPy, SciPy, and Flask, and JSON also, as well as JobLib. So only these libraries are using, rest of the things are sub dependencies. Okay, so to run this project we require these libraries. So let's close the requirement.txt file. Now we have requirement.txt file. The next thing is to create one more file, which will be the instruction manual for this particular project, and that is nothing but a readme.md file. So let's go to folder, click on new, and let's create file. The file name will be readme.md. So MD means it's a markdown file. Now this will act as a manual for your entire project. So whenever you build any particular project, make sure that you add readme.md file as well as requirement.txt file. So in readme.md file, you can select this particular option, editor and preview. So what it will do is, here you can edit your readme.md file. So using hash, you can write title, or let's say heading 1. So this is our heading 1. Here you can write the title, then here you can write heading 2, and then similarly heading 3. So if you want to write entire instruction, what are the files and how to run the code, all those instructions you can write in readme.md file. So let me remove this and add some basic details. So these are the content of the entire project. So overview, what is the problem statement, project structure. So as of now, I'm not using project structure. So let me remove that. Then setup and installation. Okay. So let me close this as well. On the left side, you can enter your entire table of content for this particular project. Then this is the overview of the entire project and what was the problem statement, and then setup and installation. So first thing in the setup and installation, you can clone the repository, and then let me write the setup and installation only. So let me copy this part. After cloning the repository, once you clone the repository, inside this bash command, you can create an environment. So let's change the title. Create conda env, and for that you can use command create -- name, create conda -- name. Name is disorder prediction. This is the command we are using, and Python version is 3.11. Python double equal to 3.11 version we are using. Once you create a command, once you create the command environment, you need to activate that environment. So activate disorder dash prediction. That's it. So here you can see we have created a second step. Now let's create third step similar way. So once you create an environment, you can run install dependencies. So to run the dependencies, you can just type this command pip install -r requirements.txt, and it will install all the dependencies. So on the left side, on the right side, you can see all the changes. Now step 1, step 2, this will be step 3. And then step 4 again. So let's copy this part. Run web app and API. So for that, you can just type To run the web application, you can just type Python app.py and it will run the entire web application. So now we have created the sample readme.md file. If you want, you can add few more details like how to run Flask API, Flask web application, Streamlit app, Gradio app, Jupyter notebook. Like that way you can add rest of the detail. And then now it's time to push the code to the GitHub repository. So now all the files, code files, folder structure, models, Jupyter notebook, data file, everything is present inside the one folder. So next step is to push this particular code to GitHub repository, and then we will deploy the entire GitHub repository, or maybe using local server, we will push the entire code to the cloud server, and over there we will deploy the final model. So that will be the next step.